Hello, fourth grade. Today we're going to review all the geometry vocabulary and concepts we have been working on this school year. The first terms we're going to review are point, line, line segment, and ray. Here we have a point. A point has no size or shape, just position. Notice here we have point M, and notice this point is labeled with a capital letter to classify this as point M. Here we have a line. A line is a straight path of points that has no beginning or end. Notice a line here, which this line XY has arrows at the end of both, at the starting and end point, because it ultimately has no start or end because it goes on and on forever in both directions. A line segment is a portion of a line that has two endpoints. Here we have line segment AB. Notice here this was line AB, but we took out that individual line segment, classifying that as line segment AB. And notice at the end for a line segment, there's a point at the start and the end because there is a set end and start point. That's what makes a line segment much different than a line. Again, a line has arrows go on both the start and end because those arrows represent that it goes on and on forever in both directions. While a line segment has an exact start and end, that's why it starts and ends with a point instead of an arrow. Now a ray is a portion of a line which has one endpoint and extends forever in one direction. Here we have ray PQ. Notice here we're starting with a point because it has an exact start point, but it has an ending with an arrow. And even though there's ending with an arrow, that arrow represents that this ray extends forever in one direction and it goes on and on. So it has a starting point and then the other end has no set end. It goes on and on forever. Point, line, line segment, and ray are all very important vocabulary words in geometry. Following this, we moved on to parallel, intersecting, and perpendicular lines. So first, we have parallel lines here. Here we have line AB and line CD are parallel lines because they never cross, even if they are extended. And in fact, no matter if you were to extend these two lines, they go on and on forever in both directions, but they will never meet ever. And in fact, they're equal distance away from each other, no matter where you are. The example of parallel lines were the two yellow lines in the middle of the street. Doesn't matter where you are and any location in the world, those two yellow lines will never ever meet, and they're always the same distance apart from one another. Now you have intersecting lines. Here we have line EF and we have line GH. These are intersecting lines because they do cross each other at point M right here. They meet forming intersecting lines. Now, perpendicular lines also intersect, but what's different about this pair of lines, here you have IJ, line IJ, and line KL. They are perpendicular lines because where they meet right here, it forms a right angle. While intersecting lines meet as well, but they don't form a right angle. And when they intersect, forming a right angle, we call that a pair of perpendicular lines instead. So they're classified under a different name because when they meet, they form that right angle, forming perpendicular lines. Then we moved on to angles. In fact, this time here, we put together two rays. And when we put together two rays and find out where they meet at something called a vertex. And this forms an angle. So again, when two rays meet, they meet at the vertex, and this forms an angle. But now that we were forming all these angles, we had to classify angles. So when we classify angles, they can either be called an acute angle, an obtuse angle, or a right angle. Now, a right angle measures exactly 90 degrees. In fact, I'm even going to draw this box here representing that 90-degree angle. An acute angle measures anything less than 90 degrees. So if I said an angle measurement was 35 degrees, right away you would know that's an acute angle because it's less than 90 degrees. An obtuse angle measures more than 90 degrees. So if you were given an angle measurement of 125 degrees, right away you would classify that as an obtuse angle because it's greater than 90 degrees. Every angle can be classified as one of these three options. Following this, we learned how to measure angles. So when I threw out the numbers 35 or 125, how did I determine those values? How did I get those degrees for each angle? I used a protractor to determine that. A protractor is used to measure the number of degrees in an angle. You learn that you have something called your inner scale and your outer scale that's used to help you with this. So if I was given an angle here, I put my vertex right here in the middle. In fact, I will draw this angle in blue so you can all see it. I have one ray that is extended on my straight edge here. Notice it's completely straight, hitting 180 degrees because this is a straight line. And now this other part of my angle, this ray, is we're going to extend this. And in fact, this angle here, we'll call this angle A, B, C. Notice B is my vertex and it's right in the middle of my protractor. ABC. So it hits 40 degrees and 140 degrees. But when I'm using a protractor, the first thing I'm going to do is classify this angle. By looking here, I could tell that this angle is an acute angle because it's clearly less than 90 degrees. So if it's an acute angle and I have to determine what will this angle measurement be, I have two options, either 40 degrees or 140 degrees. Clearly, I need to select the number choice or the degrees that are less than 90 degrees to prove that this is an acute angle. So therefore, 40 degrees is the angle measurement of angle ABC. Now, unfortunately, we don't all have access to protractors at home due to online learning. When we get back to school, I do have many protractors where you will have time to touch and feel the protractors and use the protractors effectively. However, since we don't all have access to protractors, that is absolutely fine because we can always estimate our angles instead. So here we're given an angle here called KLM. You have to select the best option for this angle. Now, I don't have access to a protractor here, but what I can do is estimate this. And the first thing I'm going to do is draw my potential 90-degree angle, my estimate. So clearly right away I see that this angle KLM is much greater than 90 degrees. So I know that this angle needs to be an obtuse angle. So whatever value I select, it needs to prove that this angle is an obtuse angle. So when I'm going through my options, I need to select something greater than 90 degrees. Now, 54 right away is less than 90, so it can't be that, and same with 21. Now, 97 degrees and 159 degrees are both greater than 90, but 97 degrees would be pretty close to my 90-degree marking, like maybe right where this red line is here would be represent 97 degrees as this angle here. But KLM is much larger than that. Therefore, the best selection for the degree measurement would be 159 degrees here. Now, maybe if you did have access to a protractor and you might say, this angle is 162 degrees. That's okay. This is just an estimate. It's not going to be exact because we're just estimating. We're not using a protractor to measure the exact degrees. We're just getting near it. So as long as you're about plus or minus about 5 degrees from that, so if you said this is 158, somebody else says this is 161 degrees, or maybe 157, those are all great estimates of angle KLM. However, in today's activities, you will see potential problems where it'll be easy to identify the best estimate. So notice I only have 159 degrees here. There's not 158 as well. So I think you will be able to clearly identify the best representation of the angles given to you. So geometry vocab is very important to develop an understanding because these terms you will be using throughout 4th grade, throughout 5th grade, 6th grade, and beyond in math. So geometry is always used every single school year. And in fact, you'll find many instances where you will be using this in the real world as well. So, as you complete today's activities, if you need to refer back to this video at any time to help you with these vocabulary words as you continue to develop a better understanding for the meanings of each of these vocabulary words, feel free to do so at any time.